Welcome everyone. In this video, I will teach you theory of logarithm. I have on the board 3 questions to illustrate that. The question says, without using tables, evaluate log 1 over 27 base 9, log 7 base 49, and log 0.0625 base 8. When we say without using tables, we are talking about calculators and 4-figure tables. That is the statistical tables. For you to evaluate these logs, there is a theory of logarithm which says that if log n base a is equals to x, then a raised to power x must surely give you n. This is the theory. If log of n base a is equals to x, then a, that's the base raised to the power x, will return n. With this in mind, we can evaluate these questions. The first one, log 1 over 27 base 9. We have is equals to, first of all, choose a letter to represent your answer, equals to x. Now, borrowing a leaf from the theory, we will now say 9 raised to power x will give us 1 over 27. We can rewrite this as 9 raised to power x equals to 27 raised to power minus 1. Then, we have to reduce 9 and 27. Reducing 9, we have 3 raised to power 3x equals to 3 raised to power 3 bracket minus 1. Going further, 3 raised to power 3x equals to 3 raised to power minus 3. Because both of them are the same, this will remove this. Finally, we have 3x equals to minus 3. Dividing both sides by 3, we'll have x equals to minus 1 as our final answer. So the second question, log 7 base 49. First of all, choose a letter to represent your answer. Let's choose y in this case. So the second question, we have log 7 base 49. First of all, choose a letter to represent your answer. Here we have y, log 7 base 49 equals to y. So the next line will have 49 raised to power y equals to 7. Going further, 49, you can reduce it to the level of 7. and that will give us 7 raised to power 2y equals to 7 raised to power 1. Why raised to power 1? Because any number in mathematics that has no power is assumed to have power 1, because 7 raised to power 1 gives you back 7. Now that both of them are of the same level, to the next line we'll have 2y equals to 1, then y will be equals to 1 over 2 when you divide both sides by 2. The third question says log 0.0625 base 8. First of all, raised to power, we equate it to an unknown, to x, which will serve as our answer. Then we'll have 8 raised to power x equals to 0.0625. The next thing we'll do is we'll change this to fraction. We'll have 8 raised to power x equals to 625 over 10,000. Then you can reduce them. When you divide with 5, continuously with 5, you arrive at 1 over 16. Then, going further, we'll have 8 raised to power x equals to 1 over 16. Of course, 8 raised to power x equals to 16 raised to power minus 1. We can rewrite it like that. Then going further, we can reduce 8 and 16 to have the same level. And that is to the level of 2. Doing that, we'll have 2 raised to power 3x equals to 2 raised to power minus 4. Now that both of them are of the same level, we bring down their powers. 3x equals to minus 4. Then x, dividing both sides by 3, we'll have minus 4 over 3. And that will give you minus 1 whole number, 1 over 3, as our final answer. In continuation of the video on log without tables, I have on the board this question. Given that log 2 is equals to 0.3010, log 3 equals to 0.4771, evaluate log 15, B log 12, and C log 40. Anytime you are given this type of question, make sure you are guided by the logs given to you. You are given log 2 and log 3. So in simplifying these logs, 15, 12, and 40, make sure you are guided by log 2 and log 3 in choosing your factors. The factors of 15, the factors of 12, and the factors of 40. The first one, log 15, will be simplified as 3 times 5. We are given log 3, but we are not given log 5. What do we do? You need to bring in an equivalent of 5. Applying the laws of logarithm, we'll have log 3 plus log 5. And I said log 3 is given, but log 5 is not given. You bring in the equivalent of log 5. So going further, we'll have log 3 plus log 10 over 2. 10 divided by 2 will give us 5. Now, why did we choose 10 divided by 2? Of course, we know that 2 is given, log 2 is given, so we don't have problem with 2. Then what about 10? I chose 10 because the base of each of these logs is 10. I have stated earlier that any log without a visible base is assumed to be in base 10. So choosing 10 will not be a problem. It is one of the easiest ways of arriving at the correct answer. The easiest ways of evaluating those logs that are not given. So I chose 10 and then 2 as equivalent of 5. Now going further, we'll have log 3 plus log. Applying the law of logarithm here, we'll have 10 minus log 2. Going further, we'll have log 3 is given, it is 0.4771 plus, then log 10 is base 10. Remember, the base is 10. So log 10 base 10 is 1. Any log to its base is 1. Then minus log 2 is 0.3010. Now 0.4771 plus 1 will give you 1.4771. Then subtracting 0.3010 from it, we will have equals to 1.1761 as our answer. So the second question, log 12. Simplifying 12, we have log 4 times 3. We chose 4 and 3 because 4 can be simplified further in terms of 2, while 3 is given. Going further, we'll have applying the laws of logarithm, log 4 plus log 3. Now, simplifying log 4, we'll have log 2 raised to power 2 plus log 3. The third law of logarithm, applying it here, we'll have 2 log 2 plus log 3. And that will give us 2 into log 2 is 0.3010 plus log 3 0.4771. Now, multiplying 2 and 0.3010 will give us 0.6020. plus 0.4771, and that will give us 1.0791 as our final answer. Going to the third question, we have log 40. Simplifying 40, we have log 4 times 10. I've told you the importance of choosing 10. 10 will help simplify it quicker. Now, applying the laws of logarithm, we have log 4 plus log 10. Going further, this will give us log 2 raised to power 2 plus log 10. And applying the law of logarithm here, we have 2 log 2 plus log 10. Now, using the values given to us, we have 2 brackets 0.3010 plus 1. Log 10 base 10 is 1. Multiplying this, we have 0.6020 plus 1. And the final answer is 1.6020. Now, a student may decide to use another factor of 40 instead of 4 and 12, 4 and 10. The person can use 8 times 5. 8 times 5 can still give you 40. And if you use it, you will still arrive at the final answer. Let's see it, how possible it is. Now, if you decide to choose 8 and 5 instead of 4 and 10, you will have something like this. Log 40 equals to log 8 times 5. And applying the law of logarithm, we'll have log 8 plus log 5. Now, you can simplify 8 further. We'll have log 2 raised to power 3. And then, log 5 is not given. You will do the same thing we did here by bringing in 10 and 2. So that will give us log 10 divided by 10 over 2. Going further, you will have 3 log 2 for this one plus log 10 minus log 2. Then, putting the values, we have 3 brackets. Log 2 is 0.3010 plus log 10 is 1 minus log 2 is 0.3010. Of course, when you multiply this, you have 0.9030 plus 1 minus 0.3010. And if you add this to 1 and then subtract 0.3010, you will arrive at 1.6020 as your final answer. So we can see that whether you use 4 times 10 4 and 10 as the factor of 40 in order to simplify log 40, you still arrive at the same answer as somebody who chooses 8 and 5. In summary, I will say that anytime you are given this type of log and you are given some values, make sure you are guided by those logs given to you. Don't bring in a factor that does not tally with what you have on the board. The only factor you can bring in at any time that can help you simplify any number in this type of question is 10. And the reason we bring in 10 is because we know that the base of any log without a visible base is 10. So 10 base 10 will always give us 1. Thank you for watching.